Problem number 45. Here is an incorrect student solution to evaluating this limit. We need to figure out what the mistakes are. So let's see, the student going from this to this, the student makes one change here, and that is moving the sine of 3x to 3 times sine x. And that is not true. This is the first mistake here, is that sine of 3x is not equal to 3 times sine of x. As an example, to illustrate this, if we plug in x is equal to, say, pi over 6, sine of 3 times pi over 6 is not going to equal 3 times sine of pi over 6. Sine of pi over 6 is 1/2, so this is 3/2. 3 pi over 6 is sine of pi over 2, and pi over 2 is 1. So at this point, the student has already made a pretty large mistake here. When the student breaks up the thing we're taking the limit here as, so there's a 1/3, the 1/3 goes there. X over sine x goes there. Limit as x goes to 0 of cosine x, that goes there. Yeah, this is fine. This is using product law for limits. We can break up this expression in 3 different ways. Okay, now the student says the limit as x goes to 0 of 1/3 is 1/3. Yeah, that's true. Limit as x goes to 0 of x over sine x is 1. That's also true. That is just something that you should know off the top of your head. Limit as x goes to 0 of x over sine x is equal to the limit as x goes to 0 of sine x over x. Those are both equal to 1. But then the limit as x goes to 0 of cosine x, we plug in 0 into cosine x, cosine of 0 is 1. And so here is a second mistake, is that this should have, going from here to here, that should have been 1. You weren't asked to do this, but I think it would be instructive to do this problem correctly. So when we have this limit as x goes to 0 of x cosine x over sine of 3x, I'm going to break it up in the following way. I'm going to multiply and divide by 3 there. I'm allowed to do that. Let me maybe put those in red to show those are new things I introduced in. I'm going to break it up as the limit as x goes to 0 of 1/3 times the limit as x goes to 0 of 3x over sine of 3x times the limit as x goes to 0 of cosine x. And so now this limit here is 1/3. This limit here we said was 1. And this limit, if we replace 3x and, up in here with like an h, something like this here, we can see that this limit is also going to be 1. So 1/3 times 1 times 1 gives us 1/3. So that's the mistakes in problem 45. It's helpful. The student, honestly, you can see here, it's more trig issues. The student whiffed on this trig thing. No, that's not a trig rule. And the student also whiffed on cosine 0. It looks like the student thought cosine 0 was 0, not 1. So these are important things to know. Okay, problem number 46. Let's just read this one off here. The student's asked to solve a certain limit, determines the limit does not exist. There were the following for the justification. I use a direct substitution property to evaluate the limit. I notice the denominator gives me a 0, therefore the limit does not exist. So just because when you plug in 0 into the denominator, using direct substitution, just because you get 0 in the denominator does not mean that you end up with it does not mean the final answer is undefined. The final answer is that the limit does not exist. take a look at this limit here. If we plug in 0 into the denominator, sorry, we plug in 2 into the denominator, we certainly get 0. But if we plug in 2 into the numerator, we get 2 squared is 4 minus 6 plus 2 is also 0. 0 over 0, we need to do more work, and that work is going to involve factoring the numerator as x minus 2 times x minus 1 over x minus 2. And now we cancel. Limit as x goes to 2 of x minus 1. The answer here is 2 minus 1 is 1. So here's an example in which when you substitute into the denominator, you get 0, but the limit does exist. So the student is wrong in the explanation, in the justification.